Hi everyone, in this tutorial I'm going to be giving you an overview of how to use the Box2D library to add physics to your LibGDX games. We're going to cover gravity, collisions, jumping, and simulating the motion of a soccer ball. To start, let's go over the starter code we're going to be using for this project. If you want to follow along with this tutorial, I'll have a GitHub repository linked in the description with the code available for you to download. First, we have the demo class. This is the class that our launcher calls, and it is a child of the LibGDX game class. We use this class to create a new screen, and in this context, the screen is an instance of another class called demo level. We initialize demo level in this create method, and we set our screen to be this level. The demo level class is a child of the base screen class, which is a custom class that I created. Let's look over the base screen class first to get a better understanding of what's happening here. In the base screen class, we have three fields. In the first field, we store an instance of the game object calling the screen. The next two fields are for the stages we want to show on our screen. In this case, the first stage is the main stage where we draw all our actors and backgrounds, and the second stage is called the UI stage, and we're going to display labels on this stage. In the constructor for this class, we set the game field and then initialize the stages to be the size of our window. The input multiplexer is set up here so that the main stage can detect single key presses. Then we have some abstract methods that the child classes will need to inherit. And lastly, we have the render method where we just call the act method on our stages, call the update function we defined, and draw all the content for our stages. Below this are some other methods that are required for the screen and input processor interfaces. Going back to demo level, here we define our tiled map and the objects present on the screen like the player. In the create method, we initialize our tiled map and create our player. In the update method, we call the player's update method, update our tiled map's camera, and then render the content. Lastly, we have this getObjectsFromMap method, which we use to extract object data from our tiled map. This method is called from our create method. As you can see, here is our tiled map. You can see that it contains many objects for coins, players, platforms, the ball, and a few dominoes, and it's all in this object data layer. We have classes set up for most of these objects in the code, and we create these objects in the getObjectsFromMap method. Before incorporating Box2D into this project, I'm going to quickly summarize the existing actor classes I have set up here. First, we have the base actor class, which we use to control the positioning and drawing of our actor. Then we have the animated actor class, which we use for sprite sheet animations. This inherits the base actor class, and we have all these methods defined for controlling the animations of our actors. Lastly, we have classes for the player, coin, ball, and domino objects. In the player class, we have methods for changing the animations, extracting images from a specified sprite sheet, and moving the actor depending on key presses. The coin, ball, and domino classes are pretty simple. All they do is set the texture of their respective objects. All of this code proceeds to give us the following results. As you can see, we can move the player around, but there are no collisions and we have no jumping or gravity. We'll be using Box2D to give us all of these features. So now that we've gone over all of the starter code, let's get into the main topic of this video, which is adding Box2D physics to our game. To do this, we need to do the following. First, we need to define a world with specific physical properties, so for example gravity, and then we need to define actors that are subject to the physics of this defined world. So the actors need to have properties for density, friction, etc. So let's start by specifying our actors first. We're going to create a new class called box2dActor.java, and let's have this class extend our animated actor class. This way we'll inherit the methods for controlling our animations and controlling the basic properties of the actor, like their size, image, etc. Okay, so then we're going to have three fields defined for this class. The first field is going to be an instance of the body class, and in Box2D we have a world class that manages all of our physics entities, performs calculations for the simulation, and reports all of the collision events. The body class is what specifies that our actor is a physical entity that needs to be managed by the world object. The next field is going to be an instance of the body def class, and this class is responsible for setting the overall properties of our body object. We'll be able to store the following properties about the body in the body def: the initial position and angle of the body, the initial linear velocity and angular velocity, where the linear velocity represents a change in position and the angular velocity represents the rate of rotation. Damping values, which if set will gradually decrease linear velocity and angular velocity over time, then the type of object, where a static object is not affected by forces and does not move, and a dynamic object is affected by forces and can move. Lastly, we have a Boolean value that indicates whether the body can rotate, which by default is set to true. Okay, so now the last field we're going to define is the fixture def field, and this is an instance of the fixture def class. Now, the important thing to know about bodies and fixtures is that individual parts of a body can be represented by fixture objects, and each of these fixtures can be represented by a single shape. So the fixture def class stores the following properties. The physical shape of the object, so if we want it to be a circle, we use the circle shape class. A polygon, we use the polygon shape class. And for a rectangle, we use the setAsBox method of the polygon shape class. Then we have the density of the object, which calculates the mass of the object. Then we have the friction of the object, which calculates the opposing force when two objects slide across each other. So a value of 0 in this case represents a perfectly slippery surface with no friction, and a value of 1 represents high friction. Lastly, we have the restitution of the object, which measures the bounciness of an object in response to a collision. So in this case, a value of 0 indicates no bounce at all after a collision, and a value of 1 would indicate that the object will bounce all the way back up to its original position from which the object initially fell. So that completes the fields we have for the fixture def, body, and body def. Now we want some constraints on the speed that our actors move at, so we define 3 new variables for max speed. The first one is just the overall max speed, and then we have 2 more for the max speed in the x and y direction. So now that we have all our fields set up, we're going to start working on our constructor. So inside our Box2D actor constructor, we're going to start by calling the super method to call the constructor for our animated actor class. And then we're going to initialize our fields. So we'll set body to null. And then for body def, we'll store a new instance of the body def class. And then for fixture def, we'll store a new instance of the fixture def class. Then for our max speed variables, we'll just initialize them to be null. And once we've done that for x and y as well, we're going to start working on our body def methods. So we need to define a few methods for specifying our body def object. So how about we start by defining the type of our object, so whether it's static or dynamic. Recall that an object being dynamic means it's free to move around, and an object being static means it's not going to move. So first, let's create our setStatic method. We're going to set our body def's type field to be static body. We can change this to a static import to make it look a bit cleaner. And then we can work on our setDynamic method, which will be pretty much the same thing. It's just that we're going to set our type to be a dynamic body. Okay, so once we have that set up, we can create one more called setFixedRotation. And in this method, we're just going to set the body def's fixed rotation to be true. Now let's look at specifying the position of our body def object and the shape of our fixture defs. We're going to create methods for working with both circles and rectangles. The first method is going to be setShapeRectangle. We're going to call it the setOriginCenter method, which can be found in our base actor class first, which is going to set our actor's origin to the center of the sprite. Then we'll set our body's position using our origin and the actor's initial x and y positions. We need to scale the body's pixel dimensions to the physics dimensions, so we divide by 100 for both coordinates. Lastly, we're going to create a new polygon shape and then call the setAsBox function on this shape, and this will define a new rectangle fixture. The body's positions are set to be the center of the shape, and the dimensions of a rectangle are specified using distances from the center. So we need to take half the total length and width, which means we're going to divide by 200 instead of 100 for the hx and hy parameters of the setAsBox function. Now that the method for setShapeRectangle is done, we're going to create another method called setShapeCircle, and this is basically going to be the exact same as the setShapeRectangle method, but instead we're going to create a circle shape. Now we're going to add some more methods for our fixture defs. So first we're going to create a method called setPhysicsProperties, and this method is going to accept 3 parameters. The first is the density, then we have the friction, and lastly the restitution. In this method, we're going to set our fixture defs values for density, friction, and restitution. Now we're just going to create some getters for the density, friction, and restitution of the fixture def. So this will be pretty straightforward. For get density, we just return the fixture def's density field. And then for get friction, we're going to basically do the same thing, except we're going to return the fixture def's friction field. And lastly, for get restitution, we'll return fixtureDef's restitution field. Next, we'll specify some getters and setters for the velocity and speed of the Box2D actor. First, we're going to define a getVelocity method which returns a vector2 object, and for this we're just going to return the linear velocity of the body. We're going to do this by calling the body's getLinearVelocity method. Then we'll add a setter method for the velocity, so we'll create two methods. The first method will have two parameters for Vx and Vy. Both of them will be floats. And then in this we'll just say body.setLinearVelocity using Vx and Vy. Then we can overload this function and create another one where we just accept a vector2 parameter. And then we'll set our body's linear velocity to be this vector. Now we're going to focus on adding some methods for determining our actor's speed. We're going to start by adding some getters and setters for our max speed variables. So we're going to define a getter and setter for each of the max speed x, and max speed y variables. Once we have methods for these three defined, we're going to create a getSpeed method. The getSpeed method is going to return the result of calling the len method of the velocity vector. We're dealing with vectors here, so the len function returns the magnitude of the vector, which we can interpret as the speed. Then we're going to create another method called setSpeed. In this method, we're first going to set the magnitude of our velocity vector, and then we're going to set our velocity vector to have this new magnitude. All that's left to do for our Box2D actor class now is to implement the methods that actually apply physics to our body. So first we're going to create a method called initializePhysics, which takes a world parameter. Then using this world object and our bodyDef, we're going to create a new body. So we'll say body is equal to w.createBody, and then we'll pass in our bodyDef as the argument. Then we'll create a new fixture using this body and the fixtureDef. We're going to say fixtureF is equal to body.createFixture. Then we'll pass in our fixtureDef. Now we set our fixture's user data to be main, which basically means that the fixture represents the entire body. Lastly, we want to set the body's user data to be this current actor. So we say body.setUserData, and then we pass in this. We're going to define two more methods now, one for getting the body and the second for getting the fixtureDef. We're going to say public body get body, and then we'll return our body. Then we'll say public fixtureDef get fixtureDef, return fixtureDef. Okay, now we're going to apply two more methods. The first method is going to be applyForce, which accepts a vector2 object, and the second method is going to be applyImpulse, which also accepts a vector2 object. For our applyForce method, we'll say body.applyForce to center. Then we'll pass in our vector2. We'll say true for the wake parameter. And if you look at this definition for this function, we can see that this will apply a force to the center of the mass and it will wake up the body. Now for our applyImpulse function, we'll do something similar. We'll say body.applyLinearImpulse. We'll pass in our impulse, our body's position, and then we'll set the wake field to true. And you can see in the definition for applyLinearImpulse, it will immediately modify the velocity. Okay, lastly, we have the act method, which is going to be called by the act method of the stage. So in this method, what we're going to do first is call our superclass. So the animated actor's act method is going to be called first. And you can see this is what that method does. So if we go back here now, what we mostly want to do is just cap the maximum speeds if they've been set. So if max speed x is set, we want the velocity to be the maximum acceptable velocity and not go past that. So we'll say vector get velocity. And then for the velocity in the x direction, we're going to call mathUtils.clamp. And we're going to make sure that doesn't go past our maximum values. Then we'll set our final velocity. Okay, and then we're going to basically do the same thing for the y direction. So it'll be the exact same, except it'll be our restrictions for the y value. And lastly, we're going to set our overall max speed. So we're going to see if that's defined. We want to get the current speed. And then we want to compare that speed with our max speed. And if it's greater than that, we want to set our speed to be the max speed. Okay, now the last thing we need to do is set our position to make sure that the actor is appearing in the right place. So we'll get our body's world center first. And then we'll call our base actor's set position method. Okay, so once we've calculated that, then we're going to get our body's angle, and then we're going to set our body's rotation as well. Now that we've gone over the Box2D actor class, we're going to start by changing our player class. We're going to change the inheritance of the player class to inherit the Box2D actor instead of animated actor. The player class is going to be a dynamic object, and we need to be able to jump from platform to platform. But to make sure that our player is actually on a platform, we're going to define a new variable called ground count. We're going to initialize this variable to be 0 in the constructor. Then we're going to create two new methods to control this variable. The first method is going to be called adjust ground count, and this is going to take an integer parameter. We're going to increment our ground count variable by whatever argument is supplied to the parameter. Then we're going to create another method, and we're going to call it isOnGround, and it's going to return a boolean. If the ground count is greater than 0, we want to return true for this method. We're going to be calling both these methods later to make sure that a player is colliding with the platform before jumping. Next, we want to implement the physics methods that are required for this class. We're going to need to define two methods. The first method is going to be called setProperties, and it's going to take a world parameter, which we're going to use to define the properties of our body object. First, we're going to define our body to be dynamic, which tells Box2D that our player is free to move around. Then we're going to set the shape to be a rectangle and specify our physical properties. This setPhysicalProperties method takes parameters for density, friction, and restitution, and we're going to define this in the constants file. So first I'm going to set density to 1.0, I'm going to set friction to 0.5, and I'm going to set restitution to 0.1 respectively. Once we have these values saved in the constants file, we're going to go back to the player class, and then we're going to access these constants and pass them as arguments to our physics properties parameters. Once we have that done, we're going to set our player to be fixed rotation. And lastly, we're going to call initializePhysics, passing in our world object as the parameter. The next method we're going to define is the initializePhysics method, which is going to be an override of the existing Box2D actor method. The first thing we're going to do in this method is call the method in the superclass. So we're going to call super.initializePhysics and pass in our world object. Then we're going to define a fixture def on the bottom of the body. We can define fixture defs on our body to act as sensors, so we're going to create a fixture on the bottom to see if the player is on a platform. Create a new fixture def for the bottom sensor, and then we're going to set it to be a sensor by specifying the isSensor field. The next part gets a bit complicated. We need to specify the shape of our sensor, and in this case, since the player is a rectangular object and we are worried about the bottom of the player, we'll define our sensor to be a box as well. So we're going to create a polygon shape here, and we're going to call it sensor shape. And on this sensor shape object, we're going to call set as box. So remember what we did when calling this function in our Box2D actor? We're going to do something really similar here, but we're going to specify the center of the fixture. So for hx, we're going to do getWidth minus 8 over 200, getHeight over 200 for hy, and then we're going to create a new vector 2 for the center. We're going to pass in arguments of 0 and minus 20 over 200f in this vector, and then specify an angle of 0. Then we're going to create a new fixture called bottom fixture, and then call body.createFixture and pass in the sensor. Then we'll set this fixture's user data to be at the bottom. So if we create our fixture like this, we should see the sensor exactly over here on the player right at the bottom. And that should help make our jumping detection fairly accurate. The last change we need to make to our player class is that we need to change the way our player moves. So we're going to remove everything we have in the player method right now, and we're going to start by specifying the max speed the player can move in the X direction. So in our constant file, we're going to define a maximum speed. So I'm going to set the max speed to be 2.0. And then we're also going to define a walk speed. I'll set the walk speed to be 3.0. Then we're going to check which key is pressed, either the A key or the D key, to control the horizontal motion. So we'll start by specifying if the A key is pressed. The A key is pressed, we're going to apply a negative force in the X direction. So we're going to say this dot apply force and then pass in a negative walk speed. And then we're going to change the way our sprite is facing as well. So we're going to say this dot set scale and then put a -1 in the X scale. Then we're going to check if the D key is pressed. And if this key is pressed, we want to do the same thing, but we want to apply a force in the positive direction. Then we're going to reset our scale so it's facing the right way. And that concludes the current modifications we need to make to our player class. Now we need to change our demo level class to incorporate the Box2D world. So first we're going to define a new field called world, and then we're going to initialize it in the create method. We're going to say world is equal to new world. Then we're going to pass it a new vector 2, in which we're going to define gravity. So we're going to set it to -9.8. And then we're going to set the do sleep parameter to true. This just means that we're going to avoid simulating inactive bodies. And then once we've done that, we're going to change our update function. So at the top of our update function, we're going to call world.step. We're going to use a time step of 1/60, velocity iteration 6, and position iterations 2. You can just keep the arguments I have defined here. I doubt you'll have to adjust them. Next, we're going to define an add solid method at the bottom of our code that's going to create a new static Box2D actor. So we'll create a private method here. This method will accept two parameters. The first will be a rectangle object, and the second will be the world. We're going to start by getting the rectangle. Then we're going to create a new Box2D actor. Then using our rectangle, we're going to specify our Box2D actor's position and then its size. This is done by looking at the rectangle's X, Y, width, and height. Then we set the solid to be a static. Then we're going to set its shape to be a rectangle. Lastly, we're going to call the initialize physics method on the solid, passing in our world parameter. Now that this method is defined, go to the objects from map method, and in the platform case, call this add solid method, passing in the rectangle object and the world. We're also going to specify our player's physics properties right now. We're going to say player.setProperties. And then in our initialize physics method in the player class, we have to specify our bottom sensor's shape. We're going to set our bottom sensor's shape to be the sensor shape. And if we run the code now, we should see that our player is no longer falling through the platform. There is gravity, it can't move up or down, it's stuck on the platform, and is able to move horizontally with no problems. Okay, so now that our player is not passing through our platforms, we're going to implement jumping into our code. To do this, we're going to create a new method called check collisions. In this method, we're going to call the world.setContactListener method. And for that argument, we're going to create a new contact listener, which will create all these methods for us. Now what we want to do is check if our player's bottom fixture is touching our platform. So to do this, we have this getContactObject method defined in our utils package. This function accepts the following parameters: a contact object, which is a Box2D class that tells us if two objects are colliding, a class object where we pass in the class we want to compare the contact to, and a string parameter where we pass in the name of the fixture to check. In this method, we start by getting the contact's fixture, its body, and then its user data. We get the name of the user data for this first object, and we do the same for fixture B. Once we have this information, we check if our first object is part of the class we're checking, and if it equals the fixture we're looking for. If it does, then we return this object. We can use this method to identify our collisions. So back in this begin contact function over here, we're going to create a new object called object P, and That's going to be the result of calling this gameUtils.getContact object method. We're going to check if the bottom fixture is colliding. And if it is, if it's not null, then we're going to specify this object to be our player. Then I'm going to adjust this player's ground count to signal that it's on a platform. Then we can also set the player's active animation to be standing. Then in our endContact method, we're basically going to do the exact same thing, except we're going to adjust our ground count to be -1 to show that it's not on a platform anymore. Then over here, we're going to override the key down method from the input processor. We're going to check if the W key is pressed and the player is on the ground. And if these two conditions are true, we want to be able to jump. So we're going to define a new jump vector. And we'll define a constant over here. We'll set our jump impulse to be 1.2. Okay, and then we'll pass that into this vector2 constructor. Then we'll apply an impulse to our player. Then we return false, and over here it should be the key code is equal to the W key. And once we have that, we can scroll up. And in our update function, right at the end here, we want to add a call to check collisions. So now we can run the game. You can see we can jump and we don't fall through the platform. So we've successfully added jumping to our game. The last part of this demo is going to cover the kicking of a soccer ball. Box2D makes it really easy to simulate rolling bodies, and I'll show you how to implement kicking. So first in the ball class, we're going to extend Box2D actor instead of animated actor, and then we're going to create a method called initializePhysics, which is going to be an override of the previous method we defined. In this method, we'll set our body to be dynamic, we'll set it to be a circle shape, then we'll set our physics properties to be the density, friction, and restitution we defined before. And then we'll call our initializePhysics method that we're inheriting. Now back in the demo level class, we're going to make some changes to the way we initialize the ball. We're going to need to access our ball outside of the getObjectsFromMap method, so we're going to make it a field at the top here. Then in the create method, we're going to create a new instance of the ball. And then back in our getObjectsFromMap method, we're going to refactor what we have written here. Then we'll call the ball's initializePhysics method. We're going to move this ball down here so that we can easily interact with it instead of climbing all the way to the top. And if we run the game now, we can see that we can interact with the ball and roll it in whatever direction we want. So the ball is a dynamic object that rolls how we would expect a normal soccer ball to roll. But now we need to implement kicking, so that's going to be the next part of this video. So before implementing kicking, I'm going to add an animation for jumping. So we're going to say player.setActiveAnimationJumping in our keyDown function. And then inside the player class, we're going to change the way we're animating with the walking. So over here, instead of checking the velocity x, we're going to check our speed by calling this.getSpeed. And we're going to see if that's greater than 0.1 to initiate walking. And if the speed is less than 0.1, we want to initiate standing. Okay, so if we run the game again, we can see now that our walking animation is working properly and our jumping animation is working properly as well. In the current setup, we're able to touch the ball and roll it in whichever direction we want. But what we want to do is kick the ball in a specific direction with greater force. So we'll do something similar to what we did for jumping, where we'll define a Boolean field called ballPlayerContact, and in the constructor, we'll initialize this to false. Then we'll scroll down to our checkCollisions function, and in the beginContact method, we want to do the same thing that we did for the player, so we're going to say object_b is equal to gameUtils.getContactObject. Then we're going to pass in our contact, the ball class, and then we're going to check if this is defined. We're also going to check if the player's main fixture is colliding with the ball. If this is not null, that means there's a collision, and that means we can set ball player contact to be true. Then for end contact, we'll do something very similar. We'll check if object B has a collision and if the ball player contact variable is set to true, and if it is, we'll reset this to false. Okay, then in our key down function, we want to assign the J key to be the kicking key. So if the J key is pressed, we want to change the player's animation to show the kicking animation. Now back in our update function, we want to check if ball player contact is set to true and that the player is in the kicking state. If both these values are true, that means we want to apply an impulse to the ball. So we define a new kick vector, and then we're going to create some constants to define the projectile motion of the ball. We're going to specify kick impulse x, be 0.4, then kick impulse y, be 0.1. We'll pass these constants into the vector2 constructor, and then apply an impulse to the ball. We run the game. You can see now if we approach the ball and we press kick, the ball goes flying like a projectile. But there's a problem here. If we try kicking in the left direction, it always just goes right because there's no sense of direction. And if we kick the left side of the ball while not facing the ball, it will still also go right. So we want to add some direction fixtures to make this better. So we're going to go to the initialize physics method inside our player class, and we're going to create two new fixtures. The first fixture is going to be for the right sensor, and the next fixture is going to be for the left sensor. Once we've created both of these, we need to specify that they're both sensors. And then for the right fixture, we're going to redefine the sensor shape to be a box. But this time we're going to place it at the end width of the player's body. So to do this, we're basically going to reflect our box across the diagonal from where it was originally on the bottom. If you pass in the following arguments, you should get something like this. And then we'll set that right sensor to have a shape that's equal to the sensor shape. And then we'll create a new right fixture using that. And then we want to set our fixture's user data to be right. And then for our left fixture, we're basically going to do the exact same thing, except we're going to change the center position. First we'll define hx and then hy. And then for the center inside our vector2, we're going to make it -20 over 200. And that should place the sensor shape on the left side of the body. Specify that the left sensor shape is equal to the sensor shape, and then we'll create our left fixture. Then we'll set our left fixture's user data to be on the left. And we'll just add some comments here to organize this better. And then we want to go back to the begin contact method of the check collisions function, and we're going to check the contact using the fixtures now. We're going to check the right fixture first, and then we're going to check the left fixture. And this time, if there is contact, we want to store the direction of where the contact is happening. So instead of having a Boolean value for a ball player contact, we're going to change this to be a string. And then the constructor will set the string to be empty. And then over here, if there's contact on the right, we're going to set it to be right. And if there's contact on the left, we're going to set it to be left. And then in the end contact method, instead of setting it to false, we just want to set it to empty. And when we're doing our checking, what we want to check for is to see if the string is empty. So if it's empty, that means that there is no contact. And in this case, we're checking if it's not empty, which basically means that we're checking if there is actually a value there. And then inside our update method, we're going to do the same thing. We're going to see and make sure that the string is not empty. If it's not empty, then we're going to see what it equals to. If it equals to right, we're going to apply an impulse in the right direction. And if it equals to left, we're going to apply an impulse in the negative direction. So if we were to run this game now, you can see we can try kicking in the right direction first and it will work as we expect. And then we can try kicking in the left direction and now it works like we expect. And the problem of not facing in the right direction is also solved. By making these changes, our kicking has improved dramatically, but we can make it even better by applying an impulse to the player when the J key is pressed. So depending on where the player is facing, we're going to apply a horizontal impulse to the player so that they move closer to the ball. And in our constants file, we're going to define a new constant called kick jump, and we're going to set that to 0.2. So if the player is facing in the right direction, we're going to apply a positive kick jump, and if they're facing in the left direction, we're going to apply a negative kick jump. And if we run the game now, we can see that as we approach the ball and we press the kick button, there's a little bit of movement for the player that moves it towards the right slightly more than it was before, which allows for a better connection with the ball. For the final part of this demo, I want to briefly go over setting up these dominoes on the top, and then specifying collisions with coins, configuring a counter on the screen. For this part of the demo, I already have the code added. I'm just going to briefly discuss the changes we made. So for the dominoes, all we did was change our domino class to extend Box2D actor, and then have this initialize physics method. It's basically the exact same as the ball class. Then in the demo level class, for the domino case, we call the initialize physics method on our domino object. For coins, the setup is a bit complicated. I'm going to start by going over processing collisions between the player and the coins. First, in the coin class, we change it to inherit Box2D actor, and then we specify the initialize physics method. In this, we set these objects to be static and have a circle shape. Then in demo level, we're going to call initialize physics in the coin case of the get objects from map method. Once that's done, we go to the check collisions method, and we check for collisions between the player and the coin in the begin contact method. If there is a collision, we add it to our remove list, and the remove list is an array list of Box2D actor objects that we defined as a field at the top here. In the update method, after updating our player, we loop through this remove list and destroy any bodies in the list. Then we clear the list. To keep track of how many coins are collected, we have a field defined called coins collected. And in the create method, we create a label for the coins collected by placing it on the UI stage. So we define a coin image and some text. And then in our update method, after checking collisions, we update this label. By implementing this code, we get the following result. If we kick the ball on the dominoes, we can see they all tip over. And when we collect coins, the coin counter increments and the coins disappear from our stage. So that completes our demo. If there's anything else you want me to cover relating to Box2D, or if you have any questions, please leave a comment down below. If you like this video, please give it a thumbs up and subscribe. Thank you for watching.